Hello everybody, and welcome to another video. Today we will be talking about Excel, and specifically Excel Solver, and how we can utilize that to calculate complex problems in a simple, fast, and affordable way. Today we'll be going over a problem for Happy Valley Bed Frames, a fictional company that sells bed frames. And I'll just go ahead and show you guys, if you haven't used Solver before, you'll just go to add-ins here at the top if you're in Windows, and Solver add-in should be one of the options here, one of these four options. And then from the home, you can just go straight to data, and from there, Solver should be one of the last options here above the analyze bar. And if you click on Solver, a long list of options and specifications will show up. These are all already preset by me to show you guys as an example, but depending on your problem what you'll want to have. Now let me just show you how I set these specifications. So in this problem, we're wanting to determine for Happy Valley's bed frames. Let me just go ahead and read the problem. It says, Happy Valley's bed frames recently received a donation of boards and pre-built bed frame pieces used for their product bed frames. The company is researching how many of each frame model they should make in order to maximize their profits. Requirements: stay within the amount of available hours only to make the number of models that resources allow for, and stay within the minimum and maximum demand. And those requirements will help us with the specifications here in the Solver problem. So if, for instance, our target is to maximize profit, so we'll set this cell for total profit, which is B22, as our objective. That was set previously, and we want to maximize that, so we'll set max here. And then this next part, by changing variable cells, we'll specify which cells we want the problem to change. And in this case, we're trying to determine how many of each bed frame we want to make, each model of bed frame. So here we have listed the different types of bed frame models. We have A, B, and C as the three different models. And these are the number to make here. So we will just set these three cells as the by changing variable cells. And by setting these as the variables, we're saying to the program that we want it to focus on changing and putting in numbers into these three cells that will maximize profit. And from there, it's important to put our requirements or our different standards that we want to meet. For instance, it might not meet demand for one of the less profitable units, and obviously realistically that won't be possible because there will be a demand for our product. So it's necessary to set different constraints in order to help the solver realistically figure out our problem for us. So in this case, let's go through the specifications. The company is researching how to maximize their profits. Requirements: stay within the amount of available hours. Okay, so for the amount of hours available, we have 130. And C8 here is the amount of labor hours used that we want to calculate. And how I set this up is I'll show you. I set this to calculate the number of assembly hours used multiplied by the number made, and then that gets calculated for each model and added up here in the cell. It's pretty simple to figure out intuitively, but feel free to comment below if you have any questions about it. And same goes for the setup for resources used. I just set up for each bed frame model to multiply by the number made, and then I multiplied that by the number required by each model. And so that calculates the number of resources used, and then when we go into the solver program, we can set that as a specification that, for example, B13 cannot be or has to be less than or equal to C13. And we have that right here at the top, actually. To show you guys how I went about this, I can delete this to show you how you go about adding a constraint. So we'll use the reference cell as the cell we want to focus on. And so that's B13. And we want that to be less than or equal to, it's already set to less than or equal to, so we can just go to the constraint. We want that to be less than or equal to the amount of boards available. And then we will add that as a constraint. And we do that for each constraint that our problem has, in this case pre-built bed frames, as well as the minimum and maximum demand for each product, so that our number of frames made per model is equal to our demand. It can't be less than 15, and it has to be at least, and it has to be less than 30 for model A, and so forth for each different model. And then we go forth setting each of those constraints. One other constraint that is pretty useful is integer, for example. We set B4 through B6 as integers, so that the number of models made is not half of a model. So just to say that we can only make one full complete model. We can't make half of a model. So we'll just set that all our input numbers as integers to make things easier on us. So to calculate our total profit, we're looking at multiplying, in this example, F12, which is the price for model A, times B4, which is the number made for model A. And then we multiply those, and then we add each of the models multiplied by the price. So we multiply the number made by the price, and we add them all together to get the total profit here. And obviously there's different costs involved that we haven't included as constraints, but the more complicated the model, you just need to add more constraints to your solver in order to take those into account. And now that we have all our constraints in place, now that we have all our equations working and calculating, we will go ahead and choose the solving method. In this case, we're going to choose simplex, just because it is a linear problem. If you were to use a nonlinear problem, then you would use GRG nonlinear. Feel free to look into the different specifics of your business problem and determine whether it's nonlinear or linear. And perhaps in the future we can do another video about these 3 different options. But today we're just going to go over using simplex. This is the quickest and most simple of the 3 options for solving methods. We really only need this for today. So once you put in the solving method and your constraints are all set, go ahead and double check all our variables, all our constraints, make sure we have everything we need and that it meets the specifications of our problem. And it looks like we're all good. Our solving method's good. Our objective and our cells that we're going to change are all good. So we can go ahead and click solve. And we get a little preview of our solution. If we like it, we can just go ahead and click OK. Ours looks all right. The resources used is within specifications, so our frames built. And all our models are within the minimum and maximum demand. So it looks like we have reached the point of optimum profit. And that's really the point of solver, is to determine either the minimum cost or the maximum profit of our business dealings, or it could even be used in supply chain to determine where we want to minimize our costs or how to minimize shipping costs. There are so many ways this tool could be used to help calculate and facilitate processes to make them more efficient. Feel free to message me if you have any questions about specific applications. But this is our video for today. Thank you for watching. We hope that if you like this video, that you like and subscribe for more content like this to help utilize technology to maximize your business. Thank you and have a good day.